Assalamualaikum and salam sejahtera. Today we are going to continue with Thevenin's theorems. Okay, in the Thevenin's theorem, it states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of voltage source VTH in series with resistor RTH. TH mean Thevenins, Okay, so this is a linear two-terminal circuit with A and B, okay, and a load. So we can replace by an equivalent circuit, okay, consisting of voltage source VTH in series with RTH. So this is a complex circuit. Actually, a lot of components inside here, and we can replace with only one voltage and one resistor. What is a VTH? VTH is open circuit voltage. So open circuit voltage and VOC at the terminals, while RTH is a resistance at the terminal when the independent. So RTH is here. So in Thevenin's theorem, okay, to find the RTH or Thevenin resistance, there are three cases we need to consider. First, if network has no dependent source. So if case 1, we need to turn off all independent source. Okay, then RTH or R Thevenins is the input resistance of the network looking between its two terminals. So in this case, okay, we have a circuit with all independent source, okay, no dependent source. So RTH equal R in here. So in case 2, if network has dependent sources, okay, in case 1, no dependent source. In case 2, network has dependent source. So what we need to do is to turn off all independent sources, but we need to leave the dependent sources intact. Okay, it is similar to the superposition theorems. Okay, so there are two approaches we can do. First one is we need to apply a voltage source, okay, because we don't have any independent source, because we kill all the independent source, so we need to apply new source here. Either we apply voltage source or we apply current source. So here in figure A is a voltage source, and in figure B is a current source. So we can apply either approach 1 or approach 2 is depends on the circuit. And also, okay, so this is examples for the case 1. If we are given this circuit, okay, if you see this circuit first, so this circuit, okay, you have to identify, oh, this one is a independent source, so has no dependent source. So we can solve this RTH using case 1. So we need to kill or turn off all independent source. Then RTH can be obtained by a simplification, either parallel or series connection. Okay, so how we find VTH? VTH is just same for all cases. Okay, we just find VTH as V open circuit. Okay, first we need to remove RL or R load to get the V open circuit. So in this case, we can use a voltage divider rule here. Okay, we need to find the value of V open circuit here. Go. Since we know that, there is an open circuit here, so no current flowing here at 7 ohm resistor. That means V open circuit will be moved to 6 ohm resistor. Then you can use the voltage divider rules and get the value of voltage at 6 ohm. So this is a V Thevenin's or V open circuit. So you can get V Thevenin's equal V open circuit equal 8 volt. Okay, so it's explained here, no current at 7 ohm. Okay, because this is we open, that means we cut the wire. Okay, just now we calculate the VTH and how to get the RTH or R Thevenin's. Okay, since the circuit has only independent source, so there is a case 1. So we kill all the source and find the R equivalent. So if the voltage, we need to do a short circuit. Okay, remember in superposition. So if current, we need to do the open circuit. If short circuit, meaning we need to put a wire like this here. If there is a current, we need to open, or we need to cut the wire. So there is a circuit. Okay, you can draw. Okay, here meaning that if you have a voltage, you need to put a wire. If you have a current, you need to cut the wire like this. So this is open circuit. So you can solve the circuit. Okay, here you need to put the wire because there is a voltage here. You put wire to make it as a short circuit. So you can calculate the RTH here. So how you're going to get the RTH? Okay, first you have to solve this resistance. You need to get the total resistance here. There is a parallel. So there is a special case. You can use the equation. Then you get 2 here. Then finally you see from here. Okay, there is 7 and 2. This is connected using the series. So you will get the R equivalent equal 9. So this is RTH. So finally, you can draw equivalent circuit or using the Thevenin's theorems. This is a VTH, this is a RTH, and you can put back the RL. If you see this circuit, okay, find the voltage across 100 ohm load resistor, okay, using a Thevenin circuit. So you have to identify either which case is this. So since this is a dependent circuit, so this is a case number 2. So what you need to do? Okay, first you remove the load. Okay, 100 ohm. So it is removed like this, Next, so from here you know, same as a case 1, you know that there is no current flowing at or in the 40 ohm resistor because AB is open. So no voltage across the resistor. Then we need to find VTH. So where is a VTH here? VTH will move here at 30 ohm. And here, So find VTH. So you can use like a mesh analysis here. So you can draw again the circuit, okay, without the 40 ohm resistor. Then you can find what is the value of VTH. Okay, so here I try using a mesh analysis. Then I write the K, V, L. So here is 6IS, voltage dependent to current. This is voltage, so depend to current. Okay, IS you will get 1 ampere. So you need to calculate VOC or VTH. So this is a equation. You get 36 IS equal to VOC or V open circuit. So you can multiply with 1 and you will get 36 volt. So VOC equal VTH equal 36 volt. Okay, next. Okay, you need to find RTH. Okay, so in this case, you need to deactivate the independent source. So you just remain all the dependent source as in the figure. So since this is a voltage source, so we need to put wire. So it will be short circuit here. And you use this equation RTH equal V open circuit divide by I short circuit. Okay, try to calculate this one using the equation to get the RTH. So in this case, I put 1 volt as a voltage source here. Okay, so I will write using KVL here to get the value of RTH. You can follow and see the equation one by one to get the value of I0. Then from I0, you can use a V0 equal 1 because we replace here as 1 volt here. So 1 volt over 0.0174. Then finally, you will get the value of RTH. Equivalent circuit. Okay, since you get RTH and VTH value already, then you can draw a new circuit or equivalent circuit, okay, using the 1 volt, 1 voltage source and 1 component R resistor. So this is a step, okay, to analyze the circuit using Thevenin's theorem.
Simple steps to analyze electric circuit through Thevenin's theorem. Open the load resistor. Calculate, measure the open circuit voltage. This is the Thevenin voltage, VTH. Open current sources and short voltage sources. Calculate, measure the open circuit resistance. This is the Thevenin resistance, RTH. Now, redraw the circuit with measured open circuit voltage, VTH, in step 2, as voltage source and measured open circuit resistance, RTH, in step 4, as a series resistance and connect the load resistor which we had removed in step 1. Now find the total current flowing through load resistor by using the Ohm's law.
Next is a Norton theorems. So Norton theorem states that a linear two-terminal circuit can be replaced by a current source I1 parallel with resistor Rn. So can you remember the source transformation? Okay, you can replace from the series to parallel resistor. So this is a equivalent circuit. We have a two-terminal circuit. Okay, from here, this is a Thevenin's. then we can convert it to Norton, okay, like this. So the voltage become convert to current, and the R resistance, R Thevenin series change to parallel. So it seems like the source transformation concept. So that's why I'm telling that the Thevenins and Nortons is quite similar. Okay, it's just we convert the V Thevenins and R Thevenins into the I Norton to R Norton. So actually R Thevenins and R Norton is same. Okay, so it's the same resistance. Okay, how you get the IN? IN is just use the Ohm's law. So IN equal VTH over RTH. So after you calculate this, you can write in the equation. So RTN is same as RTH. Only the position from the series connection we change to the parallel. So this is a Norton equivalent circuit and Thevenin equivalent circuit. If we have a 0.2 current source, we can change it to Thevenins or vice versa. So here we can calculate VTH. So what is VTH here? So VTH is equal IN. VTH is equal IN multiplied with 15 or Rn. Then you will get 0.2 multiplied with 15 and you will get VTH equal to 3 volt. So you can write T volt here. Then maximum power transfer. So maximum power is transferred to the load when the load resistance equals the Thevenin resistance. Okay, if R load is equal to RTH, so this is a meaning of maximum power transfer. So this is the red one is R load. If the value is same as RTH, so this is the place where we have the P max. So this is the equation for the maximum power transfer. So then you can use from the calculation in Thevenin's theorem. Then from that value, you can use just this equation and do the calculation to get the maximum power transfer. For example, here I use the RL equal to, then you just put the value of the VTH and RTH here, and you can get the value of maximum power transfer. You can get, okay, just use calculator and try to calculate by yourself. Here I draw the sources, either the independent or dependent. Okay, there is a two source. First is current and voltage. So this is a two basic sources, either current or voltage. Okay, there is a symbols for the independent current source, and this is the symbol for voltage source. Sometimes it draw like this, or sometimes it put like this. Then there is a dependent current source and voltage source. So there will be this box, okay, like this, and there is the arrow shows the current and plus minus shows the voltage. So the direction can be upside or can be up or down. So it is same in voltage. It can be negative, positive, or positive and negative. So you can see also for dependent current and voltage source. Okay, there are four actually. dependent sources. Okay, for current, there is two. Okay, first is this one. Okay, the arrow is 1, and the arrow is mean the current, and I meaning the current. So this is a current, depend to current. So what is the unit for this one? The unit is depend on here. So the unit here is ampere. Okay, next. How about this? This is current, and this one is voltage. So this one is current depend to voltage. So what is unit here? Unit is still ampere, because inside here is a symbols of current. So where is Ix and V1? This you need to find out in the circuit. For example, here, okay, we have a circuit like this. Then we have a current, depend on current. So you need to find somewhere here Ix, and you put the value here. And here is a current depend on voltage. So voltage is actually the value here. Okay, next is a voltage dependent. This is a symbols of voltage, and this one is current. So this one is voltage depend on current. So the unit here is a volt, and this symbol is voltage depend on voltage. So this one is also unit is a volt. However, it will see the value of Vx somewhere in the circuit. Same here, we need to find somewhere Ix in the circuit. Okay.